Okay, hello everyone. Today we're going to talk about this. This is a turbomolecular pump which we have received from another lab. It is used, abused and probably dead pump, which I will have to pull apart, check what's inside. If it's salvageable, we will salvage it. If not, well, then bad luck for us. I did not introduce the lab. I am in a lab, by the way. That's why you can hear a bit of echo. It's a small room. I will do the videos as soon as I can. I'm a bit busy right now. But first, we can talk about this pump. Oh, I'm sorry. So, actually, this is the stand that I'm using to put my phone on. It is a bit hard to operate because, well, it's in the way. Usually I don't have anything in the way between me and the stuff I'm working on. So we'll talk about this pump. This is a turbomolecular pump. Basically, it's a big turbine inside which spins like 40,000 RPMs, and it's basically that's it. This is the for vacuum part. So like usually we're closing it off with the aluminum foil so the trash doesn't get in. So this is the pre-vacuum. This is, I think, venting or purging, and this is also something like that. I think this is for nitrogen purge. This is for vent, and this is for vacuum. This is ports for water cooling. This is the port from the controller. We will talk about controllers later. And that's basically it. So this is how I received it. There's nothing going with it. And when I remove this foil, this is stuff I noticed is that it might be a bit hard to see. Like I'm looking here. Oh, actually look at my fingers. It's oil. So it's leaking oil through the for vacuum part. Oh, actually, I will just wipe it off. It can be either the oil from the for vacuum pump. It happens. It's called what was it? The bleed back? I'm not sure. There's a specific word for it when the for vacuum pump leaks oil into the turbo. It's a bad thing. It's a failure mode. Happens sometimes, but also I think that this is directly oiled TMP, by the way. So the turbine is spinning 40,000 RPMs, so it has to be really well balanced, and so logically the ball bearings inside have to be balanced really good. And well, it's not really a good thing to, I don't know, base your production upon the balanced bearings. So they're trying to use the least amount of bearings possible, which is, well, actually one. So there's only one ball bearing inside here with ceramic balls and shit. And the one on top is probably magnetic levitation. So they only have to balance the ring and it's fine. You don't have to deal with like lubrication and balls and stuff. At least I think so, because the pumps I pulled apart before were like that, and this is just this is just the protection mesh. We can remove it. It's just snugly fit in there. Yeah. By the way, this pump is from a known system. It was pumping mostly in neutral gases like argon, nitrogen, air. So I'm touching it with my bare hands. Sometimes these pumps are used to pump trimethyl aluminum, trimethyl zirconium, trimethyl, a lot of metal stuff, which is, first, it's toxic, it's not good for your skin, and in general, check what pumps are you working on first. Second, well, my hands are washed but still dirty. I'm going to wash everything inside here because it was sitting outside for a really long time. And now I'm going to test it. So first, the way to test your pump is to try spinning. And here I can already hear the rattling sound of the ball bearing, and something is catching inside, but it's not that bad. Usually when you spin it like this once, it has to spin for like at least 30 seconds freely. Then you know your ball bearings are good. Not the case here, sadly. So the way to pull it apart is different by the pump manufacturer. This one is, by the way, Turbovac. How do I show it to you? Yeah, it says Turbovac 150 CSV, made in Germany and distributed by Leybold. Actually, the made by Leybold and Turbovac is the name of the pump. So the way to pull this one apart is probably remove the oil reservoir. Oh, by the way, I'm tilting it because I know that there is not enough oil here. Usually they're strictly vertical operation, so you're not supposed to tilt it this much. Like normally the oil level has to be here, and if you tilt it, you get oil from out here. Probably this is what happened actually. So to remove the oil reservoir, you have to, I guess, it's the first time I'm pulling it apart, by the way. Probably remove these nuts. I will remove it normally. So, yeah, this is actually my normal work as a research assistant, to repair this kind of systems and make them working again. You will see later. So I have removed 3 bolts, I think, and after, if I pull, it has to get out. Yeah, it does get out. Okay, so the problematic part next is that it's going to leak oil all over the place. It will be just dripping and dripping. This pump was standing vertically like this for at least a month. I didn't have time to touch it, so I can safely assume that there's really not much oil inside. So I will be just taking a huge wipe. By the way, I'm using the clean room wipes, Team wipes. But it doesn't matter, we're not working in a clean room now. They're just really good, and I have it in my hand. So I lift it, and no, there's an O-ring as well. So first I want to remove like excess oil from here. It's the oil intake. And also the oil is really dirty. Usually it's almost transparent, it's really liquid oil. I watched some videos on YouTube of people repairing TMPs, and they usually use the specific oil, really low viscosity, low outgassing oil, or they're just using the, what was the name of the pump? The vapor jet, oil vapor jet pumps. And basically where you boil oil, you force it through the nozzles on top and it takes out gases with it. Yeah, so this one, so I will also clean a bit and turn around. This, oh yeah, and on the inside I can actually see the rotor. So this is the rotor. Wait, I need something. So this is the end of the rotor, which has a cone on it, and this cone is dipped into the oil, and it uses the surface tension of the oil and the spinning of this cone to distribute the oil right inside the ball bearing. For here, I do not really know how to proceed. So I think if I want to remove the bearing, I will have to remove this tree, because it is a serviceable part here. but I am not sure. So I guess I will just try it out, because, well, the assembly manuals not available for this kind of pumps. I could find some manuals for rotary pumps, but not for TMPs. Okay, and okay, this is too big. We're just going to. So I guess I will just pause the video here, and we will just do it later. Oh, by the way, it's a spring-loaded system here, so the bearing is never in a wobbly state. Yeah. So I will just, or probably I will not. This is, oh yeah, I can feel the spring tension, and if it can just like fling on me actually. Oh, nice. This is pretty. Oh, by the way, this is full of oil still. I will definitely wash my hands afterwards. The oil is more or less clean, more or less, but still, this is synthetic oil, not really good for your skin. Might cause like rashes and reactions and stuff. Oh, look at this spring, how beautiful it is. Oh, by the way, this part, it sided, so there is no recess here, there is a recess here. Don't make a mistake when putting it back. I will be changing all the oil, so I need to wash it first anyways, because I don't have the original oil on hand, and probably it's discontinued anyways. Like, this is the thing with this kind of pumps. They are usually working, like their work span, if serviced, is around 15 years, like almost continuous operation. But companies are like just discontinuing this shit faster than it wears out. Okay, and what do I do from here? I have no freaking idea. Which is actually pretty sad. I was expecting this to come out from here, but I believe I will have to remove the nut on the rotor. Which is pretty interesting. Maybe I can. No, it does not give. Okay, these are like this 6 nuts. They're holding the motor shield. So basically, this bottom part is brushless DC motor, 3-phase brushless DC, and that's it. It's just the direct drive of the turbine. That's it. By the way, the spring has, it's a filed spring, so it's flat here. It's flat as well. But there is no direction, I think. So it's fine. Okay, and since we removed the spring, the rotor is still moving, so yeah, probably the tension changed. I can hear more. I can hear more. Yeah, I can hear the friction, so I will not be spinning it anymore. Which is actually pretty strange. I don't remember exactly how to pull it apart. I know there is the hex nut right in the center, and if I loosen it up, the rotor and turbine might separate, but it's not the case. I was working on, what was it, Pfeiffer vacuum, I think, and they do not separate, they just separate from the case. So I guess I will try separating the top case first. So basically it separates on this line. So I will be removing the this nuts first. Oh, yeah, pretty tight. So, like, there's a lot of magnet and spring tension inside. Just be careful when you pull it apart, so you can actually service it after and pull it back together. Okay, one more. This is, by the way, just a tube. It's welded into the case. I will just leave it alone. Oh yeah, it's really loaded. And I'm wondering if I should put back the spring. Yes, probably I should. I'm not sure. Let's check the rotor. Rotor is still free. It's a free spinning one right now, but I can feel the pressure. Actually, I can remove the legs. If no, probably not. I will put it on the legs back. It will be easier to work. So along like this. I think last two bolts. Oh, this is pretty dirty. This is dirty because it was a really strange clean room. Not as clean as you would like. There was a lot of, they were working on graphite, I think, graphite and graphene production, and yeah, that kind of clean room. Like, it doesn't need to be particularly clean. It's not lithography clean room, but still, like, it was kind of filthy by my standards. But yeah, they got results, so who am I to criticize people? Okay, this is the last one, I think, and now we can put it. Oh, look what happened here. This part, which I tried to pull out before, it fell out from here. It was here, and I wonder what helped it. The fact that I turned it around, maybe. This can be, yeah, see? This is where the spring was, like the spring contact was there. And it's really dirty. I think it's just the ball bearing on the bottom. Oh yeah, ball bearing is dead. It's pretty hard to see. Ball bearing is in the, there. Wait. So this is the ball bearing part. And I can see the separator just falling apart. So yeah, it's no good anymore. It will be all washed with alcohol, it will be dried with nitrogen, it will be baked. Don't worry. At this point you can make it dirty as long as you can wash it afterwards. If you cannot wash it afterwards, however, you better do this shit in the clean room. You better wear hand protection, you better wear a suit. Just, I don't even know what you have to do. You have to be able to wash the pump afterwards. It's the main, it's the prerequisite on working with this kind of stuff. But, well, I will try not to get carried away with precautions, because if you're at the point in your life when you have to take a TMP apart and make it work, well, probably you are already familiar with everything I want you to know. Yeah, see? This is moving. And yes, but I'm really not sure how to pull it apart now, because when I put my driver here and I look at the rotor blades, basically you will understand later, but it is consists of many turbine blades and separator blades in between. So the stator, like the part that does not rotate, is connected to this, and they're going right between the blades. So even if I pull the rotor out, I will not be able to pull out the whole thingy. And for For Pfeiffer, I think there was a special key which you put inside here and which allows you to open the rotor. It is not the case here, so I will just try loosening this up. Because I tried to lift it from the center, but I saw the separator blades, the stator blades there, moving as well. So it's not how it's supposed to be. This is going to be hard. Probably there is a proper way to do it. Also, yeah, do not force your way in. This is a really soft and gentle apparatus, and it has to be worked with carefully. It does not need or like your force. Just deal with it. If it doesn't go, you're doing something wrong. So, just a bit of prying, just a bit. Don't force it too much. But yeah, this becomes problematic because this is really tight, and even if I get it loose right now, it will be quite hard to tighten back up. So I will try doing something about it. And well, first I need a bit of time to think and poke around, so I will pause the video here. Okay, I took a few minutes to think, I poked it around, and I tried to remove this part just in case if there is anything. Like sometimes they have like weird shit, really, like it's a really purpose-built stuff, so the more you can remove, the easier it is to see. And it's just my rule of thumb, if I don't see anything, I remove more stuff. And it was full of oil and disgusting, and the O-ring is dead and shit, but no use, it's just a machine part. So, but however, I poked around a bit, and I noticed that here, there's the seam, actually right here. There is a seam between the stator blades and the rotor blades. And the stator blades are, first, there's, I don't know if you can see, it's shiny a bit. There was an oil leak, so the reverse oil leak, this pump is full of oil, it needs to be washed in ethanol. We're pulling it apart anyways now. Okay, second, I found out how to pull it apart, so you don't need to remove this, so the bolt is still there. You don't need to remove it. I'm afraid to remove it anyway, not to debalance it and shit. Here in the lab, I cannot rebalance the rotor, even if I wanted to. So if I change the lower ball bearing for a good one, a balanced one, it will be still wobbling a bit. So we will talk about it later. But to remove the housing here, I will have to pry from two sides, so from here and from there. Be really careful not to bend the rotor blades, but there is a bit of gap here, which I think I can pry, but you will be mostly without my commentary, even without any camera movement, because it is really hard. Like, I need all my hands and I need all my attention, because if I bend the rotor blade, well, this pump goes straight into the trash. You cannot do anything. You can make you can make small dents on the stator blades, by the way. They are not important. They are important, okay, they are important, I know. But they are mostly spacers. So the spacing between the blades is important, but if you bend it one a bit, well, just file it flat. It's fine, it will work. Like, it will not be a peak performance pump anymore, but it will do. So, and here is the same. So when you can, like, this is basically the tube. I want to remove this tube, and I want to leave all the stator blades inside. This might be a bit hard. just a bit. And then I have to elevate my success by adding another one. By the way, I know how it's built inside because all the pumps are basically the same. So I know where to push. And it will become evident when I will pull it apart. Well, even if I break it, live and learn, I guess. Actually, I'm just looking for another screwdriver, which I can use. So, these videos, by the way, they will be long and they will be, well, sometimes boring because I'm alone here. And I cannot film everything I do. So, yeah. Yep, that's how it is. It starts the separation already. So, I just poke it from 3 sides like this. By the way, when you pass a first, 5 millimeters, it will become easy. So, because this pump was like in service for so long, it just got stuck to each other. So, it just needs a bit of encouragement. Nah, I don't want to bend anything, so I have to be extremely careful here. Yep, I managed. So yeah. So that's how it goes. Also, a bit of side stepping. Here, see? You have to look inside, always. If something was overheating or something was sucking in dirt, you will see it here. This is mostly oil, by the way. This is burnt oil. It's fine. It's the exhaust port. It comes from here. So it was just like sucking probably some sort of carbon from the reaction chamber. As far as I know, it was the graphene producing furnace, like nanometer control and shit. But look at these fields, by the way. This is most probably from the outside of the lab. It's not from the source gas or anything. But this part, hey, look. So this is clean. I do like this. It's filthy. This is from the chamber. So chamber air comes here, comes out here. Probably, I'm not sure. Some sort of pressure leveling thingy. And yeah, see? This is just a spacer. And my marks that I left are here on the side. So I made a few scar marks. I will just file them down. It will be fine. Okay, next part. For the next part, I need a permanent marker in the box. Wait a sec. Okay, I changed a few things. I moved the oil reservoir there. We are not using it anyway. But I brought a box. I brought a marker. Important part. You have to. First you have to be sure that you don't dip your marker in oil. That's first. But secondly, when you remove stuff, you have to be sure that you will be able to put it together in the exact same way. These pumps are not uniform, so the first stages are different from the second stages here. They have different compression ratios because they do. And yes, you have to take note of everything. The first one, it's the thickest one actually, and I don't really need to number it. The reason being is that, it's the only one here. So I can just put it back. But, let's be consistent and write something on it. So 0, I guess. And just put it in a way that you understand. Second, the stator blades are separating like this. Notice it can be a bit hard because it's catching on the rotor. Well, nothing you can do about it. See? It's just like, it's catching me. And even though this is rotating, I cannot remove the blade from the center. Just a bit of force, just a bit. Don't force it too much, but just a bit is fine. So, it looks like this. So, see? And it assembles this way. And this is the stage number 0. Also, the position is important. I mean, some people do it, some people don't. I mean, some companies do it, some companies don't. So, always mark everything. What I do usually, well, let's use this as a table. So, I put it in the original position. It's first. 2 marks on the bottom, like this. 1 mark on the top. And then you will not make a mistake how to put it back. Also, on every one of them, write a number. So 0, 0. By the way, these markers, they leave maybe 3-4 micron traces. Like the thickness of the marker trace is about 4 microns. We measured it. We actually used it in some experiments. But it washes away completely with alcohol or isopropanol. No problem. It will just, everything will wash away magically. No problem there. So you assemble it, then you wash it bottom to top with ethanol, for example. There are a few ways how to wash it. I will show you later. So, and it depends on how much space you have. So I cannot really afford to take all my space, so I will just stack those. So 0, 0. And I will just keep on doing that. So the next is another separator. And this is actually surprising because in Pfeiffer vacuum, by the way, it's full of oil, it's filthy, so wipe it down. Also, if you have this problem, wash your pump. There is supposed to be 0 oil here, like absolutely 0. There's supposed to be no oil here. Be careful. Also, I noticed first I noticed the mark here. It's a bit different from the one on the bottom. Oh, it also has the mark. I think they have to fit. So, 2 marks together. But also I noticed that the thickness is the same. It's the same profile. Really easy to make a mistake. Don't make a mistake. So, writing down again, number 1. And the second one. Yep. And the second one. So, I will keep doing this. Yeah, it will take a bit of time. So, this is number 1 and this is number 1. I pull it apart, we will check. So, I will probably pause the video here because this is repetitive. Quick note here. See? This is a different one. So, the shape of the stator changed. It's a different compression ratio. So, this is stage number 0, 1, this is 2. Stage number 2 is different. And in your pump, well, it might differ extremely, by the way. So, mark, and mark again. Pause again. Okay, quick note again. Sometimes you will come by these dark marks and scar marks. It means that the rotor was touching the stator and it was doing it at really high speeds. So you will see the black marks like this or entrance here. Yeah, just be aware of that. If it's completely like hold out here, you can just, you can remove half of it, it's fine. But yeah, just be careful with it. Okay, one more note. this stage number 7, starting from 0, is separatable apparently. So I think it's for nitrogen purge. So yeah, don't forget to label it, and also since it's circular, it can move this way. I think it's just press fit, like there is not much force applied to it anyways, so it's fine. And it's, by the way, it's done from the center stage, so you don't feed the nitrogen in the first stages and it will leak into your chamber after. So chamber is up usually, and so the dirty gas comes here, then it adds nitrogen through here, and well, it just goes venting from there. So yeah, and since this is in the housing, this is probably nitrogen inlet or the valve or whatever. Oh well, pausing again. Okay, I'm almost done removing the last stage, which is stage number 11. So 12 stages in total in this pump, which is a lot. Fifers I worked on were like 6 or 8 stages. However, I noticed something on the last one. It was coming really tightly. It was gripping on the sides. I noticed it was all black here. So if you scrape it, see? Absolutely filthy. With carbon buildup, well, I would expect carbon, to be honest. It's a really carbon heavy environment. But also, here you go. See? This is filthy. It's like all carbon. This will go into ultrasonic cleaning, whatever, so it's fine. But I also suspect that the rotary pump was feeding back some oil vapor. That's why it made really easy for this. Look, it's crumbling in my fingers. It was really easy for excess carbon to build up on the last stages. Like the carbon vapor doesn't go much up. Like it's few pascals and pressure, so meh. It doesn't go up really, but it deposits itself on the lower stages. So just if you see that, probably you will have to overhaul your rotary or add some like anti-bleed valves and stuff. How do you call it? Anti-feed backwards valve. Basically, when you stop this pump and you stop the rotary pump, and when you stop the rotary pump, this has to be nitrogen filled, so the oil doesn't get sucked into the turbo. So stage number 11. Even the last one, you have to write it, because the more redundancy you have in your notes is better. So this is stage number 11 and this is stage number 11. I will be washing them one by one, probably, especially the dirty ones. So yeah, it's fine. At least for now. If I have to abandon this project for a few weeks, I will not forget everything, which is good. So the last part. So this is the rotor spinning freely, but you see, even if I remove everything and I spin it spins for like 5 seconds. This is bad. I will show you how it's supposed to spin after. So here if I look from the side, you can see that it's in good condition actually. The blades are okay. And also I'm still wondering how to remove it, because I think that actually they are expecting me to remove this screw in the center. Some pumps do it, so yeah. And also it looks like the rotor itself is a uniform rotor, so even if you remove this screw, it will not disassemble the rotor part. Well, actually, if I spin it like this in my hands, I can feel the vibrations from the bearing. So it means I have to remove it, which is a bit sad actually. Usually I kind of try, oh, that's wrong. I try to keep it together as much as possible. Oh well. I have to concentrate on this one, so momentary pause, I will get my stuff, we'll try again. Okay, so my setup looks like this. This is just a more comfortable hex range. And the most important part, you need to distribute the torque. So if I grab it like this, for example, the torque will be only on the contact points between my hand and the blades. But we actually want it to be as distributed as possible, so we wrap it. And we do not apply force like this, instead we let the friction from the hand work. So if I will be, actually wrong direction like that. So yeah, so just wrap it like this, so it just tensions itself. It's not supposed to be, actually wrong again, because I want to pull it this way, so this direction has to be the wrapping one. Yeah, and it will tension itself. And then I just increase the friction just a bit. It's not that hard. Like, it's not an engine where you have to torque everything to, like, it's not internal combustion engine where there's a lot of pressure. On the opposite, this is a pretty low power environment. This always spins in the vacuum, just in really high speeds. So the key here is, well, mostly just apply really reasonable amounts of force, never exceed it, because otherwise something will break. It's a really low power mechanism. I think it consumes like 300 or 400 watts max at full power, so yeah, it's really not strong mechanism. And here we have, I don't know, what is this actually? This is some sort of shaft retention spacer, this one. It has a direction, so the direction with the bump here. So see, this is flat, and this has like a cutout, more like, yeah, it has the protrusion here near it. Really hard to show, so it has a protrusion here, yeah, right. And now it goes like this. Now we'll just leave it here somewhere. And now I think we will be able to remove the rotor. At least I hope so, because if we will not be able to, it will be really strange. I wonder if it has to be pressed out, because some of them do, but yeah, just a bit of pressure in the center did not do it, strangely enough. So the thing is that now it's mostly pressure held. And on the bottom we have the same pressure held fitting, probably. I wonder if we can unscrew it from the bottom. Really strange. Yeah, this is worth investigating, but yeah, still really difficult. By the way, when you work on this O-ring is really valuable. It's a big one, so you cannot really like buy it in a hardware store. If you break it, the pump doesn't work. And our O-ring is like fully immersed in like oil and horrible crap, so I'll be just really carefully removing it, wiping it. I'll be wiping it with silicone vacuum grease as well afterwards, but for now I will just remove it, wipe it just a little bit so it's not covered in oil. Got it. So yeah, I just carefully pull it up, 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 pu gently wipe it with, yeah. Don't pull on it, like if you pull it apart, your life will become more painful instantly. Also, the trick, the grease gets on your hands, so, and you transfer it with your touches when you try to pull it. So use 2 tissues like this. At least you will not make it more dirty than it already is. And so when it's done, more or less, like actually there is the few dents in the ring and it's pretty old, but I think if I soak it into vacuum grease and silicone grease, it'll be fine, at least for now. So for this one, however, I think I will have to pause the video and think about it again. Oh well, till the next time.